Welcome to my channel. I am Dr. A. Navneeta, Assistant Professor in EC Department, Mahatma Gandhi Institute of Technology, Hyderabad. Okay, so today I am going to discuss a topic based on the adder circuits. So whenever we go for any electronic gadget like mobile phone, calculator, robo, uh, ATM machine, washing machine, driverless cars, any gadget you take, the most important hardware component used in those gadgets is nothing but a CPU. So already I discussed in the previous video what is a CPU. CPU is nothing but a central processing unit, a hardware block which is used to take the input from the input device. That input it will process based on the program taken from the memory. The processed program for the input, it will produce the output which will be shown on the output device. So CPU is nothing but it is a hardware which is used to process the input to give the output, taking the help of the memory which is present by taking the help of the program which is present in the memory. Okay. So here in this one, whenever we get into the CPU, in the CPU we are going to have three hardware blocks. One is nothing but sub-blocks are present. One is nothing but ALU, control unit, registers. Isn't it? So what is ALU? ALU stands for Arithmetic Logic Unit. What does CU stands for? Control unit. Registers is nothing but hardware circuits which are used for storing some temporary data. So already in my previous video I told you what is ALU. What does ALU does? ALU does arithmetical and logical operation. Arithmetic operations are nothing but what? Addition, subtraction, multiplication, division, isn't it? So what are logical operation? And, or, not, XOR, NAND, NOR, whatever the logical gate operations are there, bitwise bit operation, that will be performed with the logical in the ALU. So to perform arithmetical and logical as well as shift operation, we are going to use ALU. What is the CU? CU stands for what? Control unit. Isn't it? What does ALU stands for? Arithmetic Logic Unit. Registers to store temporary data in the form of binary bits. Okay. So whatever the arithmetic operations are there, addition, subtraction, multiplication, so all these operations are performed in a hardware block ALU which is present in the CPU. So CPU example you can take ARM7 processor, ARM9 processor or ARM Cortex processor. Like that many are there, like 8086 processors. So other name given to the CPU, we can call it as central processing unit, full form. That CPU can be also called as processor, or it can be called microprocessor, or it can be called as a microcontroller, or it can be called as a computer. So any name you can be called. Once in the books if you read computer, that computer is nothing but the CPU which you are going to use in your computer system. So computer is different from computer system. If you take a single CPU, that is called as a computer. Computer system means for the CPU, if you connect input device, output device and memory to process the data and give the output, that is nothing but your computer system, like your calculator, mobile phone, ATM machine, all this comes under your computer system. Whatever the CPU which is used in your electronic gadget, that comes as a what? CPU. Okay. So here, so that is nothing but your computer CPU used. So here in this one, in the CPU, whatever the main hardware block is there, that is ALU, Arithmetic Logical Unit. Here you are going to perform the arithmetic operations. Arithmetic operations already I mentioned, plus, minus, into and division. Or whatever these arithmetic operations are there, that is performed in the ALU which is present in the CPU. Example of CPUs which I mentioned here, in the latest mobile phones you are going to use ARM Cortex processor, and in another gadgets you can make use either ARM7, ARM9 A basic processor is nothing but a 8086 processor, which is present in all the syllabus of any universities or colleges. So here in this one, whenever you want to all these addition, subtraction, multiplication and division operations, all these operations are performed based on which operation? Based on addition operation only. So here in this one, subtraction is performed using addition, multiplication is done using addition and shifting, division is also performed using the addition and shifting. So here in this one, that means to perform all the operations, you should know in the hardware circuit ALU, which is present in the CPU, how this addition operation is going to be performed. Okay, so to perform this addition operation in the ALU, we have one hardware blocks, that is nothing but half adders and full adders. Half adders and full adders. Okay, full adder. So here you are going to have half adder circuits and full adder circuits in your ALU to perform the addition which is present in the CPU. Now what is this half adder and full adder circuits? Whenever you study these logic gate circuits, adder circuits, multiplexer, demultiplexer, memory, CPU, all these circuits are going to come under digital circuits. Okay, they come under digital circuit. What is a digital circuit? Any circuits which work with the two voltage levels, that is nothing but logic 1 or logic 0. Those circuits are said to be digital circuits. So all this comes under your digital circuits. So here in the what is logic 1, already in my previous videos I told you. Whatever the high voltage, whenever two circuits work with the two voltages, that is high and low, think your circuit half adder and full adder is working with the voltages 0 to 5 volts. Whatever the 0 volt is there, that comes under logic 0, and whatever the 5 volts are there, that is going to come under logic 1. So what here the circuits which works with the voltage, two voltage values. Here I have given 0 to 5 volts, it can be anything 2 voltage value. In that 2 voltage value, whichever is the maximum voltage is there, that is comes under logic 1, and whatever the minimum voltage is that, it comes under logic 0. Whatever the voltage which we take for the digital circuit is nothing but 2 voltage level DC voltage. That is a constant voltage for the circuits. Okay. So here next we will discuss how these adder circuits are work in the ALU. Okay. First how the operations are performed in the how the operation of the adder, half adder and full adder is going to be working, and in my next video we will see how these adder circuits will be used for performing the addition in the ALU which is present in your CPU. Okay. So first we will come across half adder. Half adder, where it is present, this will be present used for doing the addition. So this half adder circuit will be used in the ALU to perform the addition, and again this ALU is used where? In the CPU. So if you take a calculator or your mobile phone, the mobile phone to do the addition, which hardware circuit will be used? ALU. And again this ALU is present in the mobile phone, which hardware circuit? In the CPU. Okay, like ARM Cortex processor in your mobile phone. So here in this, whenever you go for the half adder, remember that it is a digital circuit. Digital circuit means it will work on two voltage level, logic 1 and logic 0. Logic 1 I told you high voltage, that is 5 volts, and logic 0 is nothing but low voltage 0 volt. Okay. So I have taken the voltage range, this circuit is working with 0 to 5 volts. So in this one, what are the maximum voltage is there? That is logic 1, and minimum voltage logic 0. So here in this one, In this half adder circuit, we are going to represent the schematic with a rectangular box, and name of the half adder is represented as in short form HA. HA represents what? Half adder. Okay. So this half adder circuit used for performing which operation? Addition operation. So how many inputs this half adder circuit is going to have? Two inputs, A and B. Okay. And next, how many outputs it is going to have? Two outputs. Sum, that is going to represent as S. Next output is nothing but carry, which is going to represent as C. Okay. So remember that half adder is a digital combinational circuit which has two inputs for doing the addition, and that added result it will produce in the form of two outputs, that is nothing but sum and carry. Okay, that is about the definition of your half adder. So whenever you write any digital circuit schematic, we have to draw to corresponding truth table. So here corresponding truth table, how you are going to write? Truth table in a digital circuit represents, it is a table which represents for the given input what output you are going to get. So first you write truth table. Okay. So in the truth table, you draw the table like this. First you write down what inputs. What are the inputs here? A and B. What are the outputs you have? Sum and carry. Sum how you are going to represent as S. Output what you have? Carry. How you are going to write as C. Okay. So here whenever you go for any digital circuit, remember that for two inputs, how many inputs you have? N is represents number of inputs. For the given number of inputs, how many inputs you have? 2. For the given 2 inputs, how many combination of inputs you can give here? Combination of inputs for digital circuit, it is given as 2 to the power of n. Isn't it? So 2 to the power of n means what does it mean? 2 square. That is nothing but 4. Okay. N represents number of inputs. How many inputs you are giving? 2. So 2 square represents 4. 4 combination of inputs you can give for half adder circuit. So here how many inputs you can give here? 2 inputs A and B I am represented here. Combination of inputs means you can give 4 combinations. What are the 4 combinations you can give? 0, 1, 2, 3. These are the 4 combinations. This 0 in the 2 bit, how you can represent? You can represent as 0, 0. 1, how you can write? 0, 1. 2, how you can write? 1, 0. 3, 1, 1. One thing, it is a decimal combinations I have written. That decimal corresponding binary bits you have written here. So how you are going to convert a decimal into binary? Take 3. Already from the 6th class onwards you are studying. Conversion of decimal number into binary number. 2. 2 ones are 2 and 1 is left out. Again, what you have here? 2 zeros are 0 and 1 will be left out. So what you are going to take from down to up. So what you are going to have here? 1, 1. So till last you get 0, you do this. So what you got here? 1, 1. First you write downward, next upward. Down what you have here? 1. Next, next 1. So 1, 1. So here 3, how you can write? In binary bits, 1, 1 you can write. So in that way you have to write it. Or another way is nothing but write down like this. 1, 2, 4, 8. So what you have here? 3 you should get. 3 you should get means here into 2 bits means you take only 1, 2 only you take. 4 bits means 4, 8 you have to take. 2 bits 1, 2 only I am taking. 2 to the power of 0, 1, 2 to the power of 1. If 4 bits are there, 2 square, 2 cube. Okay, here 2 bits only there, 2 to the power of 0, 2 to the power of 1. So here in this one, to get 3, what you have to do? Here 2 to the power of 0 is nothing but 1. This is 2 to the power of 1 means 2. So if you add 2 plus 1 is equal to 3. So in this place, this is 1 and 2. 1 plus 1, if you add this and this, you are going to get 3 values. So in this way also you can write. Similarly, if you want to get 2. 2 means 2 plus, here it should be 0. So 1 here, and in place of this you write 0. Similarly, this is of what? 2. Next you go for 1. 1 how you can write? Here in 2 place 0. 1 means 2 to the power 0. 0 plus 1, 1 here. Next 0. 0 how you can write? Both in 2 to the power of 0 as well as 2 to the power of 1. You have to write 0, 0. So or you convert into decimal into binary, in that way you can do. So 0, 0, 0 you have written 0, 0. 1 you have written in the binary bit 0, 1, 2, 1, 0 and 3, 1. So these are nothing but each bit. What is a bit? 1 or 0 which we take, that is said to be the bit. Okay. So here whatever A is there, A, this is represents A and this represents B. So A I am taking first combination as 0, B also 0. Next A0, B1. Next A1, B0. Next A1, B1. Isn't it? 0, 1, 2, 3. Isn't it? 4 combination. So if we give to the half order circuit, the input as what we are giving? One input as A as 0 and another one B as 0. If you give 0, 0, what is output you are going to get here? Sum. To get here in half order circuit, you are going to use an XOR gate. Sum is produced by A XOR B, because here XOR gate is present. Carry is given by AND gate. That is written as A dot B. Okay. So here if we draw the hardware circuit for your half order circuit, here you have what? XOR gate. Isn't it? XOR gate. Next AND gate. Here you have two inputs. One input is A, another input B. This is A and this is B. Okay, this you are going to get sum and this is going to get carry. So for getting the sum, what is the one gate? Sum XOR gate you are going to use to get the sum, and to get the carry bit you are going to use which one? AND gate. So in the expression how you are going to write? Sum is given by A XOR with B. This is your XOR symbol. This you remember. A plus with the circle. Carry is given by what? C equal to A input B. AND gate means dot product. A into B. So in the XOR gate, if you give 0, 0 means what you are going to have here? Here I am giving the input as what? 0, 0. So 0, 0 if we give, what you are going to get here? Some both input. Remember that in XOR gate, if the inputs are same, the output you are going to get 0. If the inputs are different, the output you are going to get what? 1. Okay. So here same inputs are there. Same inputs means the output will be 0. AND gate, what is the A input it is receiving? 0. What is the B input it is receiving? 0. So in the AND gate, both the inputs are 1, the output you will get 1. Here what you have here? Both are 0. So output what you will get here? 0. Okay. So what is you are going to get here? Same inputs, the output is 0. Here same inputs are 0. Same inputs are 1, then only you will get in the AND gate as a 1. AND gate is given by carry here, isn't it? So different inputs here. Sum is given by A XOR B and carry is given by A dot B. AND gate product form it gives. Okay. So here same inputs, output is 0, and here same input 0. Same inputs, logic 0, the output also you will get logic 0. Next one, what you have here? Different inputs. Different inputs means what is the output you are going to get here? Different inputs, what you will get here? Output is 1 and here 0, 1 is there. If one of the input is 0, the output of your AND gate will be 0. Carry is given by AND gate. So here also you will get as 0. Similarly 1, 0 is there. So different inputs are there for this A and B. That means the output is 1. And here 1, 0 is there. So here one of the input is 0 means the output here will be 0. 1, 1 and same inputs are there. Same input means what output you will get here in the XOR gate? 0. In the AND gate, both the inputs are 1, the output will be 1. So this is about for the given input, you are going to get the corresponding output for your half adder circuit. Okay. So half adder, how many inputs it will add? 2 inputs it will add and 2 outputs it is going to produce. Okay. And each input, how many bits you are giving here? How many bits you are giving? Here A single bit 0, B 1 combination, another bit, isn't it? So next if you go for 0 1, here B will be 1. If you go for 1 0, A will be 1 and B will be 0. Next one what you have here? A1 and B1. Okay. So here in all these cases you have seen that each input A and B, how many bits it is taking? Single bit it is taking. So how many bit of addition your half adder will do? A single stage, one stage of half adder only you are taking. So a single stage of half adder, how many inputs, how many bits it is going to add? Half adder, each input is taking single bit, means a one stage of half adder does one bit of addition. Why one bit of addition? Because each input it is going to take a single bit only. So depending upon how many bits it is taking for the input, the adder will be called correspondingly. So here how many inputs it is taken? 2. 2 means single bit it is taking. That's what it is called as single bit adder. Don't say it is a single bit adder. Don't say it is a 2-bit adder. That is wrong, because 2 inputs, each input, most of the 99% will do, students will do this wrong only. Analysis is wrong. How many inputs each adder is taking, depending upon that, it will be called correspondingly. Okay. So this is about half adder. Next we will get into full adder. Okay. So next we will get into full adder. This is also a adder circuit. Okay, digital hard adder circuit which is used in the ALU, which is present in the CPU. What operation it will perform? Addition operation it will perform. Okay, so if you go for full adder, schematic will be represented with a rectangular box. FA will be written, that is nothing but a full adder. Okay, how many inputs it is going to have? 3 inputs. A, B, input C, input carry. How many outputs it is going to have? Sum and carry. C, carry output. So in the how you are going to write the truth table? Here sum is given by what equation? A XOR B XOR C in. Carry is given by A dot B plus B dot C in plus C in A. So inside your full adder, what hard gate level circuits will be present? You are going to have XOR gate, AND gate and OR gate. OR gate you are going to have. So now we'll write the truth table. Already I told you what is the truth table. For the given combination of input, what output you are going to have. So what inputs you have here? How many inputs are there here? 3 inputs, A, B, C, N. How many outputs it is going to have? Sum and carry. So how many combination of inputs you can have? N represents number of inputs. How many inputs you are giving here? How many inputs you are giving? 3. Combination of inputs, how many you can give? 2 to the power of n. That is nothing but 2 to the power of 3. That is nothing but 8. Isn't it? So the combination of inputs, different combination of inputs you can give by the expression 2 to the power of n. N represents here number of inputs. So 8 combination means you are going to write the numbers from where to where? 0, 1, 2, 3, 4, 5, 6, 7. Isn't it? In the 3 bits, 0 how you can write? 0, 0, 0. And 1 how you can write as I shown you. In the 2 bits how you can write? 3 bits here we are writing. 0, 0, 1. 2 how you can write? 0, 1, 0. 3 how you can write? 0, 1, 1. 4 how you can write? 1, 0, 0. Similarly, you can write 5 as 1, 0, 1. 6 how you can write? 1, 1, 0. 7, 1, 1, 1. So 7 I will tell you example here. 1, 1, 1 how you have written? 2 to the power of 0, 2 to the power of 1, 2 square. 2 square means how much? 4 plus 2 power of 1 means 2 because you have written 1 here. 1 into that 2. 2 to the power of 0 means 1. 1 into 1, 1. 4 plus 2, 6. 6 plus 1, 7. In that way we have written. Okay. So you write all the 8 combinations 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So this is 8 combination which I have written there. So for here, if all zeros are there, remember that in the full adder, sum and carry you are going to get 0. Okay. So in the full adder, you are giving the input as 0, 0, 1. So 3 inputs you are giving. So each of the 3 input, how many bit you are giving here? We are giving each input as 1 bit. Okay. So among the 3 inputs, if one of the input is 1, what will the output? Sum will be 1 and carry is equal to 0. That you remember. Depending upon this gate level circuit which is present in the full adder. Okay. Expression you can remember or blindly remember that among the 3 inputs, if one input is 1, the sum will be 1, carry will be 0. Similarly, among the 3 inputs, if 2 inputs are 1, sum will be 0, carry will be 1. If all the inputs are 1, sum will be 1, carry will be 1. If all the inputs are zeros, 3 inputs, okay, then the sum will be 0 and carry will be 0. Okay, next what is the other combination? I have 0, 1, 0. Among 3 inputs, one input is 1, isn't it? So sum will be 1, carry will be 0. Similarly, you have this combination. Among the 3 inputs, 2 inputs are 1. Means sum will be 0, carry will be 1. Next you have this combination. 1, 0, 0. Among 3 inputs, what you have? One input is 1. Means sum 1, carry 0. That you remember. And next combination you have this. Among the 3 inputs, what you have? 2 inputs are 0. 2 inputs are 0 means sum 0, carry 1. Next you have this. Among the 3 inputs, 2 inputs are 1. Means sum 0, carry 1. Next you have 3 inputs. Among the 3 inputs, you have, if all inputs are 1, sum will be 1, carry 1. Okay. So one example I will tell you, taking that expression. If you take sum equal to A XOR B XOR Cn, okay. So what if I take this combination A0, B0, Cn1. So 0 XORed with 0 and A0, B0 XORed Cn is 1. First take these 2 inputs. XOR operation means what you are going to do? 0 XORed with 0 means what you are going to get? We are going to get the same input means output 0. So here 1. Different inputs means the output you are going to get 1. So sum what you got 0 0 1. 0 0 1 sum 1. Similarly using this expression you can do your carry output, or blindly remember that if all the inputs are zeros, sum will be 0, carry will be 0. Among the 3 inputs, if one input is 1, sum will be 1, carry will be 0. If among the 3 inputs, if 2 inputs are 1, sum will be 0, carry will be 1. If all the inputs are 1, sum will be 1, carry will be 1. This you can remember. So here how many bit of addition it is doing for each case, one stage of full adder, how many bit of addition it is doing? All the 3 inputs you are giving, each input you are giving as a single bit. So a single stage of full adder does 1 bit of addition. This everyone concept has to be remembered. Don't say it does 3-bit addition. How it is doing 3-bit addition? It is wrong. And most of the 98% students will tell this only. Don't do that mistake. Each input how many bits it is taking. Depending upon that we say the adder does that many bit of addition. Okay. So I think you have understood the basic building block of half adder and full adder, which is used in the ALU to do the addition, which is present in the CPU. That will be present in your mobile phone, robo, ATM machine, washing machine, driverless car, everywhere. Okay, so in my next video, we will learn how to add 4-bit of addition, 2-bit of addition using this half adder circuits and full adder circuits. So if you like my video, click the like button, subscribe it, please comment.